Welcome to the TWIML AI podcast. I'm your host, Sam Charrington.
Sam is back on the road for the next few weeks. If you're hearing this on October 31st, you can catch him at Tensorflow World in Santa Clara. Next week, he'll be at Microsoft Ignite in Orlando, and the week after that at KubeCon in San Diego. If you see him wandering around, please pull up on him, say what's up, grab one of our awesome new stickers, or maybe even snap a selfie. He loves that kind of stuff. But before we move on, last week we published a show featuring an interview with Phoebe DeVries and Brendan Mead about their paper, Deep Learning of Aftershock Patterns Following Large Earthquakes. It turns out that since that interview was recorded, some questions have been raised about the research methodology used in the paper. This was brought to our attention by Rajiv Shah, a longtime listener and friend of the show, who initially raised the concerns. The issue has been covered in numerous articles, links to a couple of which we'll add to a note on the show notes page. Sorry we missed this one before publishing. Happy Halloween. Enjoy the show.
All right, everyone. I am here in Santa Clara for the Tensorflow World Conference, and I've got the pleasure of being seated with Omoju Miller. Omoju is a senior machine learning engineer at GitHub. Omoju, welcome to the TWIML AI podcast.
Thank you for having me.
It's great that we finally got this opportunity to have this chat. For folks that are listening in, we've been trying to connect on this chat for quite some time.
A year?
Maybe about a year, yeah. And not only do we get to finally have it, but we get to finally have it in person here in sunny California.
I'm nodding my head, yes.
As is typical for us, why don't we get started by talking a little bit about your background? How'd you get started and interested in machine learning?
When I got started in machine learning, it wasn't called machine learning. It was just computer science, graduate work. I think this was around 1999, 2000, and this is C++. There were no packages. You had to write everything yourself. I was taking graduate classes. I was a graduate researcher. This is what I worked on. I used MATLAB. But then I realized that this is too academic. Where are we going to apply this thing? So I pivoted to more knowledge representation on the semantic web. We had a more pressing, realistic project to work with the Department of Defense. And so that's what I did. 2012.
It's like owl ontologies
yeah,
and that kind of
stuff? Yeah, owl ontologies, yes. I will have you know, we built one of the first sensor ontologies on owl.
Oh, really?
Yes, and I think our paper is still one of the most cited in that area.
Oh, wow.
But I like that kind of stuff. I like to do modus ponens, modus tollens, first order predicate logic. I like that. It's very clean and clear.
It never quite happened for the web the way it was supposed to.
It never did. I don't know what happened. Well, actually, I do know what happened. Probabilistic models happened. Probabilistic models happen. We have lots more data. We don't have to do that logical reasoning. With enough data, we can understand the norms of things, and it's good enough. Humans are a good enough first fit model. We don't need to have the entire thing, but a good enough solution, we can take it there. So probabilistic models were good enough. And then Google came and existed. Yeah. And that was the end of that. And it works.
Right.
So I went on parental leave. And by the time I came back, all the packages had been created. There was a real ecosystem now for machine learning. And I actually wanted to study more about how people actually acquire technical knowledge. Luckily enough, I went to Berkeley where they actually had programs where I could do this. And
you entered a program
at
Berkeley. Okay.
They had this little small program. I could do that at Berkeley. And I also was listening to a lot of Jay-Z and Beyonce, to be honest. So I was like,
wouldn't it be cool? And they inspired you to...
Yeah. I like language. I love rap music. So I'm just like, you know what? Wouldn't it be cool if we actually had an NLP rap unit? Why are we always doing polka and all this stuff? I like rap music. I want to know what Jay-Z's thinking. Uh-huh. That's what I want to do. My NLP on is the rap corpus.
Okay.
So we were able to do that unit in classes. And I just wanted to investigate cultural approaches to actually acquiring technical knowledge. If people are either passionate or extremely dispassionate, but there's some kind of emotional response versus just nothing, boring.
Right.
And if people already come into an environment with mathematics and reasoning that they already have in their heads, then they're able to actually truly understand that machine learning is a statistical based approach to solving human problems. It's not it's not just derivatives and partial differential equations. It's not, yes, we use that, but it's not math. It's math applied to human context. And modeling that. That's what I wanted people to get at. So I did that, and I was really excited about it. I wanted to continue.
And so wait, the connection between that and the rap music and JC, was there a specific project that you...
Yes, I called it Hiphopathy. It was a very
Hiphopathy.
small, tiny little thing. Just like a little amuse-bouche of such a work, you know? Because you have to do a PhD. You have to get out of there. You have to do something, study it, and get out of there. And I wanted to continue working around how humans actually acquire technical knowledge. And better yet, helping humans acquire that knowledge faster and solving their problems faster. So I was like, who has the largest data on humans and computation? GitHub. Oh, it will also be in their interest to actually solve those problems too, because people are on GitHub. Technical people are on GitHub. A lot of people come on GitHub also to learn. And GitHub is where we build that technology that helps us move forward. So it would be a great place if you want to study that and actually do work in that area to go to GitHub Machine Learning. And then you could build things to actually help people learn better and get their work done faster. So I reached out to people like GitHub, became friends with them. Luckily for me, they were creating a machine learning team. They asked me to interview. The rest is history. Here we are at TensorFlow in Santa Clara.
Right. So when you first had the idea of doing this at GitHub, there was no machine learning team.
There was no machine learning team. I was just like, hey, GitHub. Hi, it's me. What are y'all doing? You must have data. What do you have? What are the plans for you? You people must have data now, because this is 2017. You existed since 2009. That's a lot of years of data. What are your plans for this data? I think you should have enough now that we can start using machine learning to help accelerate certain things. And so coincidentally, or maybe as fate would have it, the company in a couple of months decided that that's also what they wanted to do. So they were like, voila, Omoju was already interested in this. We should just have her come and interview and see if she can help us be part of this thing.
Yeah. Oh, that's awesome. And so what's the scope of the mission of the ML team at GitHub and your role in particular?
So I'm a machine learning engineer. I'm a senior machine learning engineer. I'm part of the inaugural machine learning team. Our mission is to use GitHub data to accelerate the transaction cost of to reduce the transaction cost of developer cooperation. And how do we do that? We do that by supercharging GitHub features with data. Because everything that people are doing on GitHub, we have a lot of data. So if you've written issues, we've seen a lot of those issues. So we know what issues are going to get closed faster than others, and we can help.
If you're looking at the same repos as you're seeing a lot of the same issues too.
Yeah, we're seeing the same issues over and over again, like bugs. Maybe things labeled as bugs don't get treated fast enough. Maybe, okay, how can we upvote this? Things like that.
Right.
Yeah.
And so you're building primarily kind of internally focused. Is it GitHub? What's the way to think of it? Is it GitHub features?
Yeah, it's GitHub features. They're not internal to GitHub. They are products that are put on GitHub itself.
Okay.
So one of the products we have is when you open a GitHub repo, create a new GitHub repo. Sometimes they're they give you suggestions of labels. That is a machine learning product.
Okay.
We see that you opened this repo. Maybe you want to add this level of deep learning to it. Things like that. That is an example. It's a topic. Add this topic to it.
So,
these things look like it has Jupyter notebooks in it. It has this in it. It has that. Maybe it's like the rest of everything that has all that stuff that is all machine learning. Maybe you want to put this tag on it. Things like that.
So I imagine when you were part of getting this effort started, the first thing to do was look across, GitHub and figure out where are the places that you inject machine learning. You mentioned the tags, discoverability has got to be a challenge. So, tags and search are probably a place to start thinking about machine learning.
Yes, search is a natural one. Discoverability is a natural one. There was, so when I came in, I think I was the fourth person.
Okay.
That came to the ML team. So my predecessors everybody is still within months of each other. But like, okay, one of the first things we wanted to do was around helping people find open source communities where they want to participate, because we're an open source platform. And one of the problems is you have all these skills, you come on GitHub, you want to give back some time. How do you even figure out what open source community you want to join?
Right.
So understanding user interest and using that user interest to do recommendations for like open source communities with the ideas of like, we see you do a lot of ML stuff in here. Maybe you're interested in TensorFlow.
Right.
Well, even beyond that, look, they have issues that we think you might be interested in.
Right.
And making those kinds of suggestions. So that's discoverability is one, matching with open source is another one. Another one is triaging. Like, putting labels on issues, maybe helping out with notifications, security. There are so many places that machine learning fits in. Natural language understanding of all the readmes and this and that. And GitHub is a global platform. So there are even things that hasn't even been built yet, like localization. Perhaps machine learning could actually help. If I'm reading a repo that is mostly written in Cantonese or Mandarin and I want to extract that knowledge, maybe there's a way we can actually help to do some kind of machine translation of some of the readmes. So I have some idea of what is in this repo that I could use.
Okay.
Things like that.
Interesting.
But we're at baby steps. We're just beginning.
And so when I think about kind of the scope of those types of problems and applying those problems, I'm imagining a lot of, but not everything that you're doing is looking at the code. And I'm wondering the types of tools that you use to enable that. Is it all kind of natural language processing, or are there other things that it doesn't sound like a solved problem?
No, it's not.
But, what are the types of techniques that you're kind of constantly using when you're thinking about building models based off of code?
Machine learning on code. We are lucky enough at the machine learning team that we have a sister team called Semantic Code Team.
Okay.
And these are the folks that actually build parsers and build representations of code as abstract syntax trees. It's very exciting to work at GitHub because you actually get to do the computer science you learned. Like, you learn ASTs, and then you go into the real world as a software engineer. If you're not writing compilers, often you're not using ASTs. Right. So we have a team that actually does those kind of representations, and we can then ingest the things they create to actually model and build a representation and embedding of an AST. Okay. So that's something that is experimental now. It's not something that we actually have inside the product, but these are the kinds of things that we're working on. Like, will ASTs help us get there faster? Or should we model code as an AST? Or should we model code and treat it like natural language? Right. These are all these things you have to think about. Right. Because it's not natural language.
Right. Clearly it's not.
But it's a language, and its rules are different. So maybe then the question is, how do you model a graph as an embedding? So there are all these different kinds of questions. And that is now a small little subset of people in the world who do that kind of research. And the question is there research in that area that is far enough that can be brought into a production environment, an applied environment, and can scale very, very well gracefully? So these are all the paths we actually have to now pave. Because we're not necessarily, and it has to also happen very, very fast, because we're not building something bundled in an IDE. Right. So these are all the paths we're learning how to pave.
It sounds like at least a part of your team's charter is keeping an eye on that research horizon and what's happening there, and trying to figure out which of those things are, worth playing around with, far enough along to play around with.
Yeah, and we have people who help us do that. We have our product managers who help us, the product managers help to also shape what we're going to pursue. Yeah. We have the ML team itself saying, these are things that we think these are no longer on the horizon anymore. I think we can do this now. Let's work with our product managers to actually see if we can all have this joint vision and bring this thing into the product. Then we have our, our infrastructure team saying, the infrastructure is solid enough and robust enough that we think we can scale this. So it's like multiple stakeholders. Then we have our managers, our VPs who have the longer term vision. And does this actually fall in line with the longer term vision of what we want machine learning to really help with the product? So we are a small part of a big whole, and we have multiple stakeholders. But luckily enough, we're in a place that we can all work together as one finely oiled machine to bring things to reality within maybe like a 12-month horizon.
So here at the conference, you've already delivered a couple of presentations.
Yes, two.
So what were those? What was the first one?
So the first one is understanding what's happening in the machine learning communities, because machine learning and GitHub. So I had this idea for this talk like 2 years ago, maybe a year and a half ago. One of my colleagues on our analytics team, Anna, pinged me. She was like, Omoju, you should think about doing this. And she pushed me. And I wrote half of it, and then work calls that you do, because it's not actually work. This is just like brain twiddling, like, let's see. Because we realized that machine learning as a field has existed for a very long time,
right?
But as a somewhat commercially viable field with real tooling around it, started its ascendancy around the same time of GitHub's invention. And so did GitHub help ML grow? Who knows? Or maybe it's the other way around. We don't know. But we do know that a lot of the stuff around GitHub, machine learning communities have happened on GitHub. And we have that data going back 10 years. So we can actually do like a longitudinal retrospective study of the evolution of machine learning communities on GitHub. That was the first talk. And that talk was for the contributors themselves to TensorFlow.
Okay, so quick takeaways on that talk. What did you find in that study?
Two major things happened. We had 2010, scikit-learn, pandas, IPython, Kaggle, all these things were created. 2011, I think is that, or maybe it's 2010 too, the Stanford AI course, around that time. 100,000 people log on to want to learn about machine learning.
Right, including yours truly.
Oh, good. Because Sebastian Trong, I remember when they were doing that Mars Rover challenge.
Well, I did the Andrew Ng one, so the Sebastian one was different.
Yeah. So when they were doing this Mars Rover challenge, I was also a student. My advisor, my teacher, that professor at that time was also doing the Mars Rover challenge. So it was like an academic thing, you know. So even I did not think 100,000 people. What is this? And once people did that, the following year, Udacity was created, Coursera was created.
Right.
So then you're starting to see machine learning become a commercial, viable business enterprise. No longer just academia and NASA. They're actually human VCs putting money into this thing. So it was the first sign of the AI winter we had thawed.
Right.
Now it's a real thing. And so it started picking up. Then Andrew Ng does the cats thing at Google. Google X, was it? Where they trained those neural networks to learn a representation of cats on YouTube.
Right.
I think there was a TED Talk and all this. And everybody was like, oh my God, it's coming. Then we see another great rise. Then Theano, Cafe, all these things are created. And then Google.
All of these the rise and these inflections that you're speaking to is based on like
stars
GitHub
on GitHub.
right?
So this is using GitHub stars as a proxy of human interest in these packages. And I did an analysis of quarter-over-quarter growth of stars on GitHub repos of all these packages from 2009 all the way to 2019 to actually see if what is the growth of stars on these packages from a quarter to quarter. And we noticed a trend. I noticed a trend, howbeit it's just 3 cycles, from 2012 Q4 to Q1 2013. There is a massive spike. We see the same thing, I think, around 2015 or no, either 2015 to 2016 or 2016 to 2017. Another massive spike. The third cycle, which would be around 2019, no spike. So it's only 10 years worth of data, but no spike. And for the first time, if you look at all the stars of all the major repos in machine learning, we're talking about your TensorFlows, PyTorch, Caffe, XGBoost, scikit-learn, Jupyter, and so on and so forth. For the first time in a while, for 3 quarters straight, cumulatively, the number of stars are trending down.
Interesting.
So the question is why? Is this the beginning of another AI winter? I don't think so, because if you look at VC funding, I don't think it has accelerated at all. And if you look at the .ai domain, these things are just going up. More and more people are going to NeurIPS. NERP is no longer an academic pursuit.
Right.
It's now
right.
becoming like, I don't even know what it is. So it's not necessarily slowing down. So somebody asked a question and said, did you look at the production framework repos, things like Kubernetes, Kubeflow, things TF serving? Like we looked at those ones and I realized I hadn't done that. So I'm going to go back to the office and look at that to see maybe that's where we're putting our energy because we're actually putting things into production now.
Right.
Or is it that it's no longer trending because it has become a permanent part of software engineering? It's no longer a trend. It's just is.
Or it could be that we've solved all the problems.
We've not solved any problem. Did you come here in an autonomous vehicle? I don't think so.
Exactly. Well, and what's interesting about these three phases is that they map very cleanly or directly, I guess is the better word, to my own experience, right? So in that, I think it was 2011 timeframe when Andrew did his course. That was that first wave. I was in that wave doing that course, and then in the 2015, 2016 wave, this podcast was started out of kind of feeling the energy that is this inflection point that you're talking about, and maybe the silent echo, we call it, like this last, these last couple of years. This
year. We're in Q4 2019, going to Q. Maybe something's going to happen over Christmas.
Right. Well, I think what's happening from my perspective, what's happening is that a lot of the energy and investment is going into making it real and productionalizing, operationalizing a lot of the experimentation that's been happening. And so I'm very curious to see what you find around these frameworks. But even then, I think, and what I mean is the higher level, like the production frameworks, Kubeflow and others.
Yeah, the production frameworks.
But even then, a lot of it is people like building their own stuff off of the low level things and just kind of demonstrating value of first kind of building that kind of smooth glide path and then using that to demonstrate value. And it could be that, what we're seeing now is, ultimately the growth in kind of the broader market is people kind of reaping value. And a lot of that value is internal and not shared.
So
and
that's
not
what
be...
I was also thinking about. Maybe it has actually gone to private repos in enterprises.
Yeah.
And so we don't look at any private repos.
Right.
But one thing, I don't think we're going into a winter. But I do think we have a solid 5 to 10 years to say that machine learning is not a trend, though. Because some of the challenges is our lovely friends at the media have written all these stories, these wonderful stories. Everybody has high expectation. In 5 years, I am hoping that the car I have now is the last vehicle I will ever own. Because I'm hoping that by that time, there should be an autonomous vehicle that I hope car ownership would actually go away. Maybe I just buy some Uber credits or some company of the future thing.
Right.
And I just have transportation solved.
Right.
And the idea of me as a human being owning a car, driving it, becomes a hobby like polo. So if I want to drive, I go on a track. But it's not like a transportation thing. That is my idea of what the next 5 to 10 years is.
Right.
If that doesn't happen, though, machine learning might then just have become truly a fad. That'll be the downside, but I doubt that will happen because there's too much. Look at Google search. BERT is already helping with Google search.
Right.
Like there's a real there, but I want to see other companies outside of the major Silicon Valley big ones really have a real win with machine learning. Not Google, not Facebook, not Microsoft, not GitHub. I want to see a company that doesn't exist today and in 5 years from now revolutionize the world. That for me will be when we've truly arrived. Yeah.
No, I am very confident that we will see that. And we probably already know some of those companies. And, if they, they're probably already starting these projects that are going to do that. But the other thing that what you said made me think of is this kind of the hype cycle, technology adoption hype cycle that I think Gartner popularized or created, but it might have come before them. Or been someone else. But, kind of an inevitable part of this hype cycle is the trough of disillusionment.
Yes.
Right. So the peak of inflated expectations is kind of, maybe where we were in 15, 16 or where we are today. Who knows? But at some point, the hype kind of catches up to the market.
Yeah.
Right. And then, there's a bit of a retrenchment, not necessarily a winter, but it's,
a bit of a contraction. Just
a bit of
small
a contraction. People working hard to kind of create value. And then I always forget what the next one is. Plateau of productivity, I think. That's where you get value out of it. And I think we're kind of, the different sub technologies of ML and AI are in different places on this curve.
Yeah.
But I don't think we should be too surprised that there is a trough, and that we come out of that trough and, ultimately get value out of this stuff.
I hope so. I really hope so.
Yeah. Yeah. So that was the first presentation.
That was the first presentation.
And what was the second presentation?
The second presentation is about machine learning as a product itself.
Okay.
One thing we've noticed is there's so many hobbyists and people really, really getting their feet wet into machine learning, and they don't have any path to production. They're not inside a big company. They're an individual contributor inside their home, writing a model, and they want to move forward. And so we realized that we actually have a path to production within GitHub data app ecosystem, because we have something called the GitHub Marketplace. And in GitHub Marketplace, you can put an unverified GitHub app on the marketplace. And so my colleague Hamel realized that, I could actually build an ML model and put it in a GitHub app and push it to Marketplace, and people can actually use it to solve problems on GitHub itself, especially for open source. And
so independent of ML, what are the kinds of things that I might find in the GitHub Marketplace?
There are lots of apps. I think there are Kanban apps, but there are lots of apps around software engineering.
Yeah.
Just the software engineering process workflows. There's all kinds of apps.
Okay.
Like maybe you open an issue or a new pull request and something says hi or something like that. They're just any kind of thing that you can hook into a GitHub webhook, you can build an app around. So there are people who use a lot of stuff.
Okay. Got it.
And so we realized that we care a lot about open source. We also do a lot of work around natural language processing, the kinds of stuff that we are tinkering with, experimenting with within GitHub itself. One of the ways we can move our experiments forward is actually maybe something is not all the way quite ready to be a full-on product yet. You need to work out some of the kinks of it. One thing you can do, a low commitment way to get it continue to go, is to actually push it on the marketplace and have users use it. So you can learn the utility of it, you can iterate on it, and anybody can do that. Especially when it comes to machine learning itself as a community on GitHub. Like we've been talking about the hype cycles. What those things actually mean is people's weekends and weeknights. The maintainers of this frameworks spending inordinate amount of hours working for no pay often to build the things that we all use, we take for granted. Somebody built pandas. Somebody built NumPy.
Wes Kinney in that case.
Yes. And sometimes they built this before they joined a corporation. We write a Python thing, you put your import pandas as NPD.
Right.
Somebody's put time for free often to make that happen for you. And that person is one person having to deal with 600 contributors. Sometimes it's 4 maintainers dealing with 600 contributors. So the amount of maintainer to contributor flow, it's just not tractable. So sometimes you don't get the kind of response you want in open source, which affects the health of the open source community itself. One thing we realized very, very early on is that machine learning can actually automate a lot of those challenges away. Machine learning could actually triage some of your issues for you by putting labels on it, pushing it to the right person. And you, as a person in the ecosystem, can get access to GitHub data through GitHub Archive, which is actually inside of Google BigQuery. You can extract information.
Meaning the code data or the lifecycle data or
the
all of the
behavioral
above?
data.
Right.
The behavioral data. You can use that data to train models. We now have code data. We publish code data in something called Code SearchNet. We just did that, I think, last month. So we have like 6 million snippets of functions that we've cleaned for you. We've parsed in multiple languages. We have JavaScript, we have PHP, we have Python, we have Java. So we have all these data sets that you can actually start using to build models. And then better yet, we have GitHub apps that you can then push your app into production and people can use it and give you feedback. And it can be a virtuous cycle for helping keeping the health of our ecosystem alive. And we had our partner, Jeremy, who works at Kubeflow, who's one of the lead developers of Kubeflow, who is a customer of the issue label bot that Hammer, my colleague, wrote. And so we're talking about that entire virtual cycle. Like, you want to really start contributing to machine learning, start by building these apps to help keep the health of the machine learning communities themselves good. And we're using TensorFlow to do that.
You've got these data sets that you make available, both about code, not to mention the code that's on GitHub itself, but these data sets, as well as the interaction information, and you provide the ability for folks to create applications that interfaces with, or interacts with rather, the GitHub users and repos, things like, tagging issues and
notifications, any kind of event on GitHub.
Yeah.
Whatever it is.
Yeah.
Somebody started a repo. They could write something to just interact with that.
Right.
Somebody forked your repo. You could just say, oh, thank you. What do you want to use it for? You could write a bot to do that.
Yeah, right. So I was going to say, it sounds a lot like a bot. Like, do you think of them as bots essentially,
They're bots,
or they're
but
bots? Yeah.
Bots can have ML in them.
Right.
You know, it's just, it's a way to get something to users. It's a path to build a product.
Yeah. So as opposed to, if you are playing around with machine learning and want to do something interesting, as opposed to building your own website or building a UI, something with a UI and having to deal with all that, you can build a GitHub bot, and you've got this marketplace of people that can connect to your GitHub bot and kind of take advantage of it.
Yeah. And if you want to, you can get a verified ID and make money.
Yeah.
Nothing stops you, but you can actually start adding value. You can understand that machine learning is not some dilettante pursuit.
Right.
That it is a set of technologies to solve real human problems. And you can start doing that immediately. You don't have to wait to be part of a company and then do your ML within that company and then push it to users. You have the power now to do end-to-end.
And so did you go into, like, how technical was the presentation? Did you go into some of the, the details of how you would go about doing that, or?
Not really, but we have lots. We're going to release those slides. We have, if you don't know how to write in Flask, there's a course that we recommend. We put all the events there. We put snippets of the queries that you can use in BigQuery. So we get everything that you would need. We point you to all the right sources and tutorials that you can actually recreate this. And the issue label bot itself is open source, so you can see every single thing.
So let's talk a little bit about the issue label bot. It's a bot. It's responding to an issue's created, and it's has access to the content of that issue.
Yeah, and it's labeling it as a bug, feature enhancement, question. It's just adding labels to it. And something as simple as that is so powerful in giving maintainers back hours.
And so the idea is, GitHub has its own kind of automated issue labeling that it's doing, correct or no?
No, not really. We don't have the automated issue labeling just yet. We're starting to do the automated issue labeling.
So your group, you mentioned earlier, your group is kind of thinking about how you might do that at the scale of GitHub. But if someone you're not doing it because you can't do it. You have to deal with the scale, but someone could take this issue label bot, and what does that mean to take that? Do they have to take that and then plug their own model in?
No, they don't have to plug their own model in.
Doing?
They just take it. It's connected to their GitHub repo, and the bot just starts working.
And what is the bot able to do? What labels is it able to? Is it
those three
primarily
labels.
Labeling?
Yes, it does. To an issue, it says, is this a bug? It labels it as a bug. If it's a bug, if it recognizes, it predicts, oh, this looks like a bug.
Okay, somebody said not working, or
then
whatever.
It puts it then it opens it, it puts an issue, it puts another comment in the issue. This looks like a bug. If you think it's a bug, say thumbs up or thumbs down. If you say thumbs up, it adds the label bug to it. So it does its prediction and asks you to verify. And you can say, yes, it's a bug. And that just reinforces it, learns. So it just helps to triage for you.
Got it.
With those simple labels. Something as simple as that.
Bug and what?
Bug, enhancement, or question.
Got it.
Maybe it's a feature request. I would like this to do that. Or how do I, whatever, question. Those three simple things. And that gives maintainers back hours. Because this is what humans had to read.
Right.
And say, okay, somebody's job was just
tagging these.
Tagging.
Yeah, yeah.
This is what, everything that we do, this is how these things get done.
Right.
It's somebody doing all this kind of work.
Right.
But that person, if we can give them back their hours, it's great.
Right.
And especially for building a robust ecosystem of machine learning, GitHub is the home of all developers, including machine learning developers. The virtuous cycle is you can actually do things to make the ecosystem more robust and solve our own problems by leveraging, by thinking of GitHub as a platform. Instead of just code repository hosting, it's also a platform you can plug and build things on top of.
Got it.
So we ourselves in the ML team, we build things on top of that platform as open source. And it's just a way to also just play with things that you're experimenting with. Like if you're writing a little experiment, why not open source it to see if it's actually useful? And maybe if it's useful, you then add more time to it and you actually build it all the way up.
Yeah. And so this issue label bot, it's something that you could immediately start using and get some value out of. And it sounds like the Kubeflow team is using that.
The Kubeflow team is using it.
Okay.
And they're getting a lot of value out of it. The person that wrote the bot is downstairs, Hamo. He wrote the bot. Jeremy is also with us in the talk. He's using that bot to triage his maintaining his project because they want to keep the health of that project very high. They want people to continue to contribute, and they want the turnaround to actually getting things done.
Right. Nobody wants to go to an issues list and see a bunch of issues that haven't been responded to.
Exactly.
And tagging is the first step in
That's the first step to figure out where should it go.
Right. And so, but this is not just a tool. It's also an example for other folks that might want to build their own tools.
Absolutely.
Using machine learning that connect into the GitHub experience.
Yeah, basically it's just saying, hey, you want to write code, you're doing ML and you care about developer productivity, or you care about doing stuff around ML on code itself. Maybe you want to start playing around with an idea of automated pull request review. Here's a code base for you that we've cleaned up. We've built some things ourselves. We have a baseline of what we think the model is. We've done something. Here's the baseline we got. Maybe you want to work on that and beat that baseline. And then publish it. So it's just like getting things done faster.
So I'd be remiss if you just mentioned ML on code. I'm curious about, I'm sure others are curious about the generative side of this. Is that something that you're exploring in your group at all?
I am not exploring the generative side of it. I think it's something that we've had ideas on. Like that, to me, that would be the ultimate moonshot.
Yeah.
And part of that code challenge
what's the GPT-2 for?
Kind of things like that, right?
Exactly, right?
That is the ultimate moonshot. So people have started doing work around that. But the thing has to be good enough to be able to compile. So there's a version of this.
But you've got, that's like an adversarial thing, right?
Yeah, but a version of this could just be code completion.
Yeah.
The challenge is, though, we are not necessarily an IDE.
Right.
From a GitHub perspective, if I put on the hat of like a GitHub product manager, we're not necessarily an IDE, right? The person that would really, really rock and roll on that stuff is the person that is doing an IDE.
Yeah.
That could just, because sometimes as technologists, we fall in love with the technology. And now we're trying to shoehorn it in. Who is the customer for that technology? Everybody always talks about, I would like to just say, I want to do this, and it writes the code for me. Well, even if that's what you want to get at, who's the customer for that? Is the person that has like an IDE or some environment where you write code. We don't necessarily, maybe in the future we will, right now write code within GitHub. So from a generative perspective,
I guess I can see that from...
Our managers are not going to give us like the thumbs up to go and be chasing something that we can't. Like that's not our job. We should be doing other things that are... we are not researchers. We are not a research shop.
I think
our shop is build something within a 12-month horizon to help our customers today. It's very, very clear.
The flip side of that, though, is that you are in a position that not many organizations are in terms of the volume of code that you have access to. Although,
Google also has code. But they probably don't have as much on all the different languages as GitHub does.
Right. And, structured metadata about the code. And, so there is, it does seem that there is a certain, part of this is, do you have the market? And maybe the IDE, has the market for this feature, but they don't necessarily have the code, right? they couldn't.
Yes.
Right? Because they just
chicken and an egg.
Right.
They don't have the code. So where does GitHub fit?
Right.
And I think this is the beginnings of Code SearchNet. If they don't have the code, could we provide some of the code for them?
And so this is Code SearchNet is this
a code
repository
challenge.
of.
It's a code challenge.
Okay.
Replete with a data set filled with code itself. Parsed snippets of code and then sequences of code and their doc strings in natural language. Put out there to accelerate development on these issues. Understanding that we actually have customers today that we need to be building stuff for.
Right.
But we also want this long-term horizon. So maybe we have this.
Let's just see if anything interesting happens in this petri dish that we put out there.
But I will make sure that when I get off this talk and I talk to my manager and our VP, I will tell them that our community might like us to start doing this. And so if they give us the thumbs up to chase that, then perhaps there's a GitHub research that is created, and GitHub research then is tasked with doing this kinds of work.
Yeah, I mean,
maybe this is the beginning of GitHub research.
yeah, maybe it does seem like there's this asset available in open source code that you're uniquely positioned to take advantage of, and who knows what it's kind of classic innovator's dilemma. Like this is our current business, so we kind of have the blinders on and we're focused on this current business, but you also are in this very unique position to kind of leapfrog that and do something potentially interesting.
Yeah, and GitHub machine learning is almost 3 years old.
Yeah.
January 2017.
Yeah.
So that's also what you have to remember.
Right. No, so very different. I was just curious, very different problem for sure. With the code challenge, for those that don't have a team that does ASTs sitting right next to them, are there kind of off the shelf tools that folks are using to play around with that kind of stuff?
There are many parsers that are available that have their own version of ASTs that can parse ASTs for you. So I can't mention any of them off the top of my cuff, but they are available.
But that's the thing. Like, look for ASTs and parsers and kind of mash that up.
But we don't know yet. We don't know. This is research. So get all the representations. If I were doing this, I'll get the code represented as an AST. I will represent the code as natural language. I'll just do everything.
Yeah.
And then do the science and see which one gets you further.
Yeah.
And then, join the leaderboard and submit your model and join the leaderboard. And let's actually see how far you perform.
Like a Netflix prize kind of thing where you've got $1 million.
I don't think it's $1 million. I think there's just bragging rights of I did this.
Okay.
Your prize is you're helping your community.
Right. Awesome. Well, Omoju, it was so wonderful to finally get a chance to chat with you. Thanks so much for taking the time to be on the show.
Thank you for having me.
That's our show for today. To learn more about today's episode, visit TWIMLAI.com/shows. If you missed TWIMLCon or want to share what you learned with your team, be sure you visit TWIMLCon.com/videos for more information about TWIMLCon video packages. Thanks so much for listening, and we'll see you next week.